In this video, we will export and import data with various file formats using a real database. This includes exporting and importing data using a CSV file format. To export and import data, we will use the psql command line tool using the copy to and copy from commands. We will also use the import-export data option located in pgAdmin, which is a free open-source graphical administration and management tool for PostgreSQL databases. We will also use pgdump command line tool to export data and pgrestore command line tool to import data. The SQL code examples that are used in this video are available in GitHub for viewing or download. See the link in the description section of this video. CSV is short for comma-separated values. This file format lets you store data in plain text, which makes it great for sharing data across applications and platforms. A CSV file contains rows of data corresponding to individual records. The first row is usually a column header that contains column names. As the name of the format suggests, the values in each row are separated by a comma. Although commas are the most commonly used separator, other characters, such as semicolons, tabs, or spaces, can also be used to separate values. The copy command moves data between PostgreSQL tables and standard file system files. The copy command is a CLI, or command line interface command. So you'll need to use the psql command line utility in order to use the copy command. Prior to running your first copy command, to export or import data, run psql command in your local PostgreSQL server. The syntax for psql is shown here. The copy from command is used to import data from a file to a table. The copy to command is used to export data from a table to a file. The where option can be one of the following shown here. This copy command will export all rows from a table to a text file using the default tab delimited text file format. To copy data to a CSV file, we will use the following copy command. This copy command will export all rows in a table, select the data format as CSV, specify that the file contains a header with names of columns, specify the delimiter as a comma, and specify that null values are exported as a string value of n/a. The force quote option forces quoting to be used for all non-null values in each specified column. Some characters may trigger errors when imported back to the database, so it is good practice to enclose them with quotes. This option is only allowed in copy to and only when using a CSV file format. In this example, we will use a query instead of a table name with the copy to command. Notice that the query should be enclosed in parentheses. In this example, we will compress the exported file using gzip. Note that this requires that gzip is installed on your machine. Next, we will copy data to a file as a binary format. When using a binary format, the following options are not allowed: null, default, and header. Using binary format is somewhat faster than the text and CSV formats, but a binary format file is less portable across machine architectures. If your CSV file is comma delimited, but there is a comma contained in the data, that could cause an issue when importing them back to the table. In this case, use the quote option to quote these values that contain a comma when exporting. In this example, we will show how to export data using the copy command. First, we will click on the Start button and launch a command prompt window, followed by resizing the window. Then navigate to the bin folder where PostgreSQL has been installed. Next, we will use psql to connect to the equipment sales database. Here we include the host name, the port number, the username, and the name of the database to connect to. Then we will enter the superuser password that was created during the Postgres installation. Now we will use the copy command to copy the contents of the customer table to a text file, which is the default format. Here we can see that 6 rows were copied. Then, using Notepad++, we will open the contents of the file that was just created, and we can see that it uses the default tab delimited text file format. Next, we will copy data to a CSV file that includes CSV format, column header, a delimiter as a comma, which can be the pipe symbol, semicolon, or anything appropriate. And nulls will be displayed as n/a. Viewing the CSV file that we have just created, we can see how the column header has been added and all of the data has been separated by commas. In this next example, we will copy data to a CSV file that uses a query instead of a table name. Here we can see that only 3 rows of data have been copied. Next, we will view the CSV file that was created, and we can see how only 3 rows were added because it returns rows where account number is greater than 3,000. Some characters may trigger errors during import. If so, you will need to enclose them in quotes. So in this example, we will copy data to a CSV file, forcing quotes for specified columns, in this case, the name column. To do this, we will use the force quote option that includes the name column. This option is only allowed in copy to. Viewing the CSV file that we have just created, we can see how the data for the name column has been enclosed in quotes. In this next example, we will copy data to a compressed file using gzip. Note that gzip will need to be installed prior to running this command. To install gzip, just follow the instructions located in the description of this video. Here we can see that a compressed archive folder has been created. Next, we will export data as a binary format rather than a text file, using the Format Binary option. Here we can see that a binary.dat file has been created. If your CSV file is comma delimited and there is a comma in the data, that could be problematic when importing them back to the table. So use the quote option to quote those values with a comma when exporting. Next, we will append data to the customer table where the data contains a comma. Now we will use the quote option to quote those values with a comma when exporting the data. Next, we will open the CSV file that was just created. Here we can see that the data that contains a comma is enclosed in single quotes. In order to have a successful import, use copy from with the same options that were used during the export. For importing from a basic default text file, use the same options that were used during the export, but replace the to with from. Note that from appends data to a table. To import from a CSV file, use the same options that were used during the export, except replace the to with from. Importing from a file that used the force quote option is not allowed with the copy to. To import from a compressed file, first decompress the file using the gzip-d option. Then rename the file to filename.csv. Then use the same options that were used to export, replacing the to with from. To import from a binary format file, use the same options that were used to export the data, and replace the to with from. In this example, we will import the previously exported files using the copy from command. Next, we will remove the contents of the customer table using the truncate command. We will also use restart identity, which automatically restarts sequences owned by columns of the truncated tables, and cascade, which automatically truncates all tables that have foreign key references to any of the named tables. To import the data from the default text file we had exported earlier, we will use the copy command along with the from command. Next, we will use a select statement to show the data that was imported to the customer table. Next, we will delete the contents of the tables. Now we will import to the customer table data from the customer.csv file. Note that we are using the same options that were used to export this data. Next, we will use the select statement to show the data that was just imported. Now we will exit from PSQL. Next, we will uncompress the customer.gz file. This command will remove the customer.gz file and create a customer file with no extension. Next, we will rename the customer file to customer_from_gzip.csv. Using PSQL, we will reconnect to the equipment sales database, and then remove the contents of all of the related tables. Now we will copy data to the customer table from the uncompressed CSV file that we just created. Next, we will view the data that was just imported. And then remove the contents of all of the related tables. Now we will import data to the customer table from a binary format file. Next, we will view the data that was just imported. And then remove the contents of all of the related tables. Now we will import data to the customer table from a CSV file that used the quote parameter. Next, we will view the data that was just imported. Here we can see that the imported data that contained the comma was imported successfully. When importing data, there can be an issue with conflicting primary IDs and foreign keys. For example, here we have a customer table with primary IDs and an orders table with primary IDs. The customer underscore ID column contains foreign keys that reference the customer table. Let's say we want to import data from the customer.csv file into the customer table. This, however, would cause an error since primary keys are not allowed to have duplicate IDs. The same issue would occur when attempting to import the orders.csv file into the orders table. Also, the foreign keys customer underscore ID in the orders table would need to be updated if the ID column in the customer table is changed during import. In order to resolve this issue of conflicting IDs, we will need to create a customer staging table and an orders staging table. Then import the customer.csv file into the customer staging table and import the orders.csv file into the orders staging table. Note that when loading the CSV files into the staging tables, we will keep the old IDs exactly as they exist in the CSV. Next, we will insert the customer staging table to the customer table, excluding the old underscore ID column. Then we will map the customer staging.oldID to the newly created customer.id. New customer ID will be used to update the foreign key customer ID in the orders table. Next, we will copy the contents of the orders staging table to the orders table, excluding the IDs. Then, based on the mapping of the old customer ID, we will copy the new customer ID to the customer ID of the orders table. In this example, using pgAdmin, we will look how to reassign primary and foreign keys during an import. First, we will open a query tool window. Then we will create the customer staging table, the orders staging table, and the customer ID map table. Next, we will import data from the customer CSV file to the customer staging table. Here we can see the data that was just added to the customer staging table. Next, we will import data from the orders.csv file to the orders staging table. Then we will view the data that was just imported to the orders staging table. Next, we will add code that will insert data from the customer staging table to the customer table using a common table expression named inserted. This will return a virtual table named inserted. Then we will save the ID mapping into the customer ID map table using a table join. Next, we will view the rows in the customer table. Here we can see the rows that were added from the customer staging table. Next, we will view the data that was added to the customer ID map table. New customer ID contains the newly created IDs in the customer table. Let's take a closer look at the SQL code we just executed. First, we imported data into the customer staging table. Then we used a common table expression named inserted. This inserts data into the customer table from the customer staging table. Note the new IDs that were created in the customer table. Then returns a virtual table named inserted. Next, we will insert data into the customer ID map table. Here we will select the old ID from the customer staging table and the ID from the inserted virtual table. Then, using the account number column, which has been defined as unique, we will join the customer staging table to the virtual table inserted. This will form a mapping of the old IDs to the new customer IDs that were just created. Next, we will insert data from the orders staging table into the orders table, which will include the remapping of the foreign key customer ID. Here we will use a table join that joins the customer ID map table to the order staging table. This ensures that each foreign key points to the new customer ID. Next, we will view the data in the orders table. Here we can see the data that was added to the orders table, which includes the remapping of the foreign keys for the customer ID column. Let's take a closer look at the SQL code we just executed. First, we imported data into the orders staging table. Then, using a table join, we joined the customer ID map table to the orders staging table. This ensures that the foreign key points to the new customer ID. Next, we inserted data from the orders staging table into the orders table, which includes the remapping of the foreign key customer ID as seen here. It is good practice to wrap this in a transaction so that if any part fails, nothing will be committed. To do this, we will use begin transaction and commit transaction. In this example, we will look at the different ways to export and import data using pgAdmin. First, we will view the data of the customer table. Then we will select the Save Results to File. Then enter a file name named Customer from pgAdmin. Then click on Save. Next, we will open the saved file using Notepad++. Here we can see the CSV file that was created from the customer table. Let's close the view of the customer table. Next, we will select the Import/Export Data function for the customer table. First, ensure that Export is selected. Then we will select CSV for the format. For encoding, UTF-8 is generally the best choice. Its wide compatibility supports a range of characters from different languages, making it suitable for international data. It is the most commonly used encoding for web and database applications. It reduces the risk of data corruption when importing/exporting special characters. The on-era option is only available for copy from when format is text or CSV. Log verbosity is used in copy from when on-era is set to ignore. Next, we will select the Options tab. Then we will select Header that will include table header with data rows. Then for our delimiter, we will select comma. For the quote option, we will use the default of double quote. Note that this option is only allowed when using a CSV format. For the escape option, we will use a single quote. Note that this option is only allowed when using a CSV format. The null string option is a string that represents a null value. In our case, we will just leave it blank. The default string option is a string that represents a default value and is only allowed with copy from and not using binary format. So this option is disabled. Next, we will select the Columns tab. For columns to export, we will select All Columns. The forced quote column is only allowed with copy to and when using a CSV format. For this example, we will not select any columns. The Not Null Columns option is only allowed in import and when using a CSV format, and is disabled in this case. The Null Columns option is only allowed in copy from and when using a CSV format, and is disabled in this case. Then enter the file name to save the exported data to and select OK. Using Notepad++, we will view the data that was just exported. Here we can see the data that was exported from the customer table. Next, we will view the data of a table named Customer Import. Here we can see that the table contains no data. Next, we will select the Import-Export Data function and ensure that import is selected. Next, enter the file name to import. For our purposes, we will use the same settings that were used when we exported the data. Then select OK. Then we will execute the select statement for the customer import table. Here we can see the data that was imported from the file. The pgdump tool is mostly used as a database backup tool rather than an export tool. But since it can give you backups in different formats and let you select the tables for a backup, it can also be used as an export tool. pgdump is a command line utility that can be accessed in the bin folder of where PostgreSQL has been installed. In this example, ver is the version of the installed PostgreSQL. The positive part of pgdump over copy is it can export all of the tables in one command, where copy can only export one table at a time. pgdump can also include the table structure, not just data. You can dump structure only, data only, or both. Here we will go over some of the basic command line options used for pgdump. The -h option specifies the host name of the PostgreSQL server you are connecting to. The -u option specifies the username to connect to the database. The -w option prompts for the password to authenticate the connection. The -f option specifies the output format of the backup file. The available formats are: the -p option creates a plain text SQL script file. The -c option creates a directory output format. The -d option creates a directory with one file for each table and large object being dumped. And the -t is a tar format. The -f option is either a full path and a file name, or a folder or directory name, depending on the format used. dbname is the name of the database to export. The -t option is optional. You can specify a table name or pattern that you want to dump into the output file. The -a option is optional. and dumps only the data, not the table structure or schema. The -s option is also optional and dumps only the schema, not the data. In this example, we will take a look on how to use the pgdump command line utility. First, we will launch a command line prompt window. Next, we will resize the window. Then we will navigate to the bin folder where PostgreSQL has been installed. Using pgdump, we will output a plain text SQL script file for the equipment sales database. Or you can use the -fp command line option that also defines the output as a plain text SQL script file. Next, we will enter the password that was defined during the installation of PostgreSQL. Using Notepad++, we will take a look at the SQL script file that was just created. Here we can see the create table statement for the customer table and the create table for the orders table. Here we can see that the data to the customer table will be imported using the copy from statement. And the data for the orders table will also be imported using the copy from statement. In this example, we will use pgdump to output commands to drop all of the dumped database objects prior to outputting the commands for creating them. This option is useful when the restore operation is to overwrite an existing database. The -c option outputs commands to drop all database objects prior to outputting the commands for creating them. The ifExists command line option will use the drop ifExists commands to drop database objects during import. This will suppress the does not exist errors that might be reported. You can only use the -c ifExists for plain text SQL files. Using Notepad++, we will look at the SQL script that was just created. Here we can see all of the ifExists commands have been added to overwrite an existing database during the restore operation. In this example, we will output a tar format archive that is suitable for input into pgrestore. The -ft command line option will output a tar format archive. The tar format archive is compatible with the directory format, where extracting a tar format archive will produce a valid directory format. However, the tar format does not support compression. When using the tar format, the relative order of table data items cannot be changed during restore. Here we can see that an uncompressed archive file containing a directory structure of individual table data has been created. Next, using pgdump, we will create a directory format archive. Using the -fd command line option, we will output a directory format archive that is suitable for input into pgrestore. This will create a directory with one file for each table and large object being dumped, plus a so-called table of contents file describing the dumped objects in a machine-readable format that pgrestore can read. This format is compressed by default using gzip and also supports parallel dumps. Here we can see that a directory format archive has been created, which has a directory with one file for each table. The format is compressed by default using gzip. In this example, we will use pgdump with the -fc command line option to output a custom format archive that is suitable for input into pgrestore. Together with the directory output format, this is the most flexible output format in that it allows manual selection and reordering of archived items during restore. This format is also compressed by default. Here we can see that the compressed custom backup file has been created. Next, we will take a look at the steps on how to restore a database from a plain text SQL file that was created using pgdump. First, we will remove the database using the dropdb command with the following command line options. Then we will create the database using the createdb command with the following command line options. Then we will use psql command to import the plain text SQL file using the following command line options. To import data from a non-plain text format archive that was created by using pgdump, we will need to use the pgrestore command. To restore a database from an archive backup, we will use the pgrestore command with the following command line options. The uppercase C option creates the target database before proceeding with a restoration. If the lowercase c option is also specified, it will drop and recreate the target database before connecting to it. The lowercase c option drops any existing database objects before recreating them. The if exists option suppresses the does not exist errors that might otherwise be reported. This option is not valid unless the lowercase c option is also specified. The D option is used since pgrestore needs to connect to an existing database to create the new database that is specified in the backup file. In this case, we would specify Postgres for the DB name. And file name specifies the location of the archive file or directory for a directory format archive to be restored. In this example, we will take a look on how to restore the previous files that were created using pgdump. First, we will launch a command prompt window. Then we will resize the window. Next, we will navigate to the bin folder where PostgreSQL has been installed. Then we will drop the equipment sales database by using the dropdb command. Then enter the host name and the port number, the Postgres username, and the name of the database to drop, followed by entering the Postgres password. Then we will create the equipment sales database by using the createdb command. Next, we will use the psql command to restore a plain text SQL script file. We will enter the name of the database to restore to and the name of the PostgreSQL script file, followed by the password for the Postgres user. Here we can see the contents of the script file being executed. Now we will select all of the data for the customer table, followed by the password for the Postgres user. Here we can see all of the data from the customer table that was restored. Next, we will select all of the data from the orders table, followed by the password for the Postgres user. Here we can see all of the data from the orders table that was restored. Next, we will restore data from a plain text SQL file that was created using the -c if exists option, followed by the password for the Postgres user. Here we can see the contents of the script file being executed. Note the presence of the drop commands due to the use of the -c option. Now we will select all of the data for the customer table. Here we can see all of the data from the customer table that was restored. Next, we will select all of the data from the orders table. Here we can see all of the data from the orders table that was restored. In this example, we will use pgRestore to restore from a non-plain text format. The uppercase C option creates the target database before proceeding with the restoration. The lowercase c option drops any existing database objects before creating them. The if exists option used with the uppercase C option ignores errors if the database being created already exists. The -d option, along with the Postgres database name, is used since pgRestore needs to connect to an existing database in order to create the new database that is specified in the backup file. Next, we will specify the name of the backup file to restore from. Then enter the Postgres password. Now we will select all of the data for the customer table. Then enter the Postgres password. Here we can see all of the data from the customer table that was restored. Next, we will select all of the data from the orders table. Then enter the Postgres password. Here we can see all of the data from the orders table that was restored. In this next example, we will use pgRestore to restore from a directory format. Then enter the Postgres password. Now we will select all of the data for the customer table. Then enter the Postgres password. Here we can see all of the data from the customer table that was restored. Next, we will select all of the data from the orders table. Then enter the Postgres password. Here we can see all of the data from the orders table that was restored. Now we will use pgRestore to restore from a custom directory format. Then enter the Postgres password. Now we will select all of the data for the customer table. Then enter the Postgres password. Here we can see all of the data from the customer table that was restored. Next, we will select all of the data from the orders table. Then enter the Postgres password. Here we can see all of the data from the orders table that was restored. I hope you found exporting and importing data with PostgreSQL helpful. If you have, click on the like button. And to receive any updates to this channel, click on the subscribe button. Thank you so much for watching.